Brain repair and BDNF increase with intermittent fasting. Introduction to brain repair. Brain repair refers to the brain's ability to recover from injury and enhance cognitive functions. Recent studies suggest that certain practices, such as intermittent fasting, may boost brain repair mechanisms. These mechanisms include increased production of brain-derived neurotrophic factor, BDNF, which supports neuron growth and survival. Understanding BDNF. Brain-derived neurotrophic factor, BDNF, is a vital protein that plays a key role in supporting the survival of existing neurons, promoting the growth and differentiation of new neurons and synapses, enhancing cognitive functions such as learning and memory, acting as a crucial mediator in brain plasticity, which is essential for adapting to new experiences and environments. Role of intermittent fasting. Intermittent fasting is a powerful tool for promoting brain health. It enhances the production of brain-derived neurotrophic factor, BDNF, a protein crucial for brain function. BDNF supports the survival of existing neurons and encourages the growth of new neurons and synapses. The increase in BDNF through intermittent fasting can improve cognitive function and resilience against neurodegenerative diseases. Mechanisms of brain repair. Neurogenesis. The brain generates new neurons, particularly in the hippocampus, aiding in learning and memory. Synaptic plasticity, strengthening or weakening of synapses, allowing the brain to adapt to new information and experiences. Neurotrophic support. Growth factors like BDNF, brain-derived neurotrophic factor, play a crucial role in supporting neuron survival and growth. Inflammation and repair. Controlled inflammation helps in clearing debris and promoting repair after brain injury. BDNF and synaptic plasticity. BDNF, brain-derived neurotrophic factor, plays a crucial role in enhancing synaptic plasticity. Synaptic plasticity refers to the ability of synapses, the connections between neurons, to strengthen or weaken over time, in response to increases or decreases in their activity. Increased BDNF levels are associated with improved brain function, learning, and memory. Intermittent fasting has been shown to increase BDNF levels, thereby promoting better synaptic plasticity and cognitive function. Intermittent fasting benefits. Boosting brain health. Intermittent fasting can lead to increased production of brain-derived neurotrophic factor, BDNF, which supports brain health and function. Reducing inflammation. Regular fasting periods can help reduce inflammation in the body, which is linked to various chronic diseases. Enhancing cognitive performance. Fasting may improve cognitive functions such as memory and learning by supporting neurogenesis and synaptic plasticity. Neurogenesis and brain health. Neurogenesis is the process of creating new neurons in the brain. It plays a crucial role in maintaining and enhancing cognitive function. Increased neurogenesis is linked to improved memory, learning, and overall brain health. Scientific studies on BDNF. BDNF and brain health. Brain-derived neurotrophic factor, BDNF, is crucial for the survival and growth of neurons in the brain. Cognitive function. Studies have shown that higher levels of BDNF are associated with improved cognitive function and memory. Neuroplasticity. BDNF plays a significant role in neuroplasticity, which is the brain's ability to reorganize itself by forming new neural connections. Mood regulation. Research indicates that BDNF levels are linked to mood regulation, with potential implications for treating depression and anxiety. Fasting and cognitive function. Mental clarity. Intermittent fasting can enhance mental clarity by promoting the production of brain-derived neurotrophic factor, BDNF. Improved focus. Fasting helps improve focus by stabilizing insulin levels and reducing inflammation in the brain. Neuroprotection. Regular fasting periods can protect the brain against neurodegenerative diseases. BDNF boosting strategies. Intermittent fasting. Engage in intermittent fasting to naturally increase BDNF levels, enhancing brain performance and cognitive function. Regular exercise. Incorporate aerobic exercises like running, cycling, or swimming to boost BDNF production and support brain health. Impact on neurodegenerative diseases. BDNF and fasting, brain-derived neurotrophic factor, BDNF, is crucial for brain health and cognitive function. Intermittent fasting has been shown to increase BDNF levels, which may help in slowing the progression of neurodegenerative diseases. Disease progression. Enhanced BDNF levels can protect neurons, potentially delaying the onset and progression of diseases such as Alzheimer's and Parkinson's. Improved outcomes. Patients practicing intermittent fasting may experience improved cognitive outcomes and overall brain function. Diet and BDNF levels. Omega-3 fatty acids, found in fish like salmon and sardines, these support BDNF production. Antioxidant-rich foods, berries, dark chocolate, and green tea can enhance brain health. Whole grains, brown rice and oatmeal provide steady glucose, supporting brain function. Folate-rich foods, leafy greens and legumes help maintain healthy BDNF levels. Exercise and brain repair. Physical activity. Engaging in regular exercise plays a crucial role in enhancing brain-derived neurotrophic factor, BDNF, levels. BDNF and brain recovery. Increased BDNF levels support brain recovery by promoting the growth and survival of neurons. Neuroplasticity. Exercise-induced BDNF enhances neuroplasticity, aiding in the repair and adaptation of the brain. Fasting protocols and results. Different fasting methods. Intermittent fasting, alternating cycles of eating and fasting. Known to enhance brain health and increase BDNF levels. Time-restricted feeding, eating within a specific time window each day, which has been shown to improve cognitive function. Alternate day fasting, fasting every other day, which may lead to neuroprotective effects and elevated BDNF. Extended fasting, fasting for longer periods, potentially leading to significant increases in BDNF and brain repair. BDNF and mental health. BDNF, brain-derived neurotrophic factor, a critical protein that supports the survival, development, and function of neurons. Emotional well-being. Higher BDNF levels are associated with improved mood and reduced symptoms of depression and anxiety. Neuroplasticity. BDNF enhances neuroplasticity, which is essential for learning, memory, and overall cognitive function. Long-term effects of fasting. Sustained benefits for brain health. Intermittent fasting has been shown to support long-term brain health by promoting the production of brain-derived neurotrophic factor, BDNF, which helps in the growth and survival of neurons. Cognitive function. Over time, fasting can lead to enhanced cognitive function, including improved memory and learning abilities. Neuroprotection. Regular fasting may offer neuroprotective effects, potentially reducing the risk of neurodegenerative diseases. Case studies and testimonials. Real-life examples. John's journey. After incorporating intermittent fasting into his routine, John reported enhanced cognitive function and memory retention. Emma's experience. Emma noticed a significant improvement in her mental clarity and focus, attributing these changes to her fasting regimen. Mark's transformation. Mark shared how fasting helped him overcome brain fog and increased his overall mental well-being. Challenges and considerations. Nutritional deficiency. Ensuring adequate nutrient intake during fasting periods can be challenging. Adherence. Maintaining consistency in fasting schedules may be difficult for some individuals. Individual variability. Different people may experience varying effects from fasting. Medical conditions. Those with certain medical conditions should consult healthcare professionals before starting fasting. Cognitive impact. Initial cognitive decline might occur as the body adapts to fasting. Future research directions. BDNF mechanisms. Investigate the molecular pathways through which BDNF enhances brain repair and cognitive function. Fasting protocols. Explore different intermittent fasting protocols to identify optimal patterns for maximizing BDNF levels. Long-term effects. Conduct longitudinal studies to assess the long-term impact of fasting on brain health and neuroplasticity. Population studies. Examine the effects of fasting and BDNF across diverse populations to understand individual variability. Summary of key insights. Brain repair. Intermittent fasting promotes brain repair by enhancing neurogenesis and reducing oxidative stress. BDNF increase. Fasting significantly increases brain-derived neurotrophic factor, BDNF, which supports brain health and cognitive function. Neuroprotection. The practice of intermittent fasting offers neuroprotective benefits, potentially reducing the risk of neurodegenerative diseases. Metabolic benefits. Intermittent fasting improves metabolic health, which indirectly supports brain function and repair.